Hello everyone, back tuning in for the 10th Winter 2017-18 update from GazWeathers.com. So, since the start of September, we've done 9 updates. This is the 10th Winter 2017-18 update. And once this is out of the way, we've only got 2 more updates to go. We've just got updates 11 and 12, one more third and final seasonal model roundup, and then that's going to be it. We'll be out of time, and on Sunday, the 3rd of December, we will have to issue and release the GazWeathers.com Winter 2017-18 forecast. So we really are getting very, very close to crunch now. We are coming down to, we're definitely in the business end of the winter updates, and we are coming to the closing stages. So it's been a fascinating year of updates, getting season of updates. Many of the drivers are in unique states, so it makes, again, a very complicated forecast. How often do we have to say that these days? And it is going to be difficult to get winter forecast together, but we will get it together, and it will be issued on Sunday, the 3rd of December. So, for the 10th time, we are going to have a look at all the drivers. We're going to have a look at things like solar activity, what's happening with the oceans in terms of sea surface temperature, anomalies, and what's happening in the ENSO region as well. And this video specifically, this 10th update, is going to focus on active hurricane seasons and the winters that follow those active hurricane seasons. I'll talk you through all of that in a moment, but we're going to begin where we left off last week, looking at warm Octobers, because for the 9th update, I had a real nightmare with the recording. There was a crash while I was recording it, so I had to start all over again with the 9th update at around 11:30, 12:15 at night. I was still trying to get the video up to YouTube at around 2 o'clock in the morning on the Sunday, and basically the whole thing was a nightmare, and I didn't have time to get everything in that I wanted to fit in with the warm October. So I'm going to show you the rest of that for the start of this 10th update, picking up exactly where we left off with the 9th update last week. So I'll get on with that for you in a second. Before I get on with that, though, just to say that the Christmas shop is open, so if you've got any Christmas shopping to do at Amazon between now and Christmas, please click the green button that says Christmas shop. It'll take you to our Christmas shop page, and then from there, the key to it all will be to go through the Amazon banners. By going from GazWeathers to Amazon, we get a revenue fee on the things that you buy once you get to Amazon. So you're not doing anything different. You're certainly not having to spend any extra money. You just do your Christmas shopping as normal, but you go from GazWeathers to Amazon via the Christmas shop page, and from going from our website to theirs means we get a revenue fee on things that you buy. And a big thank you to everybody for doing that again this season. This can be quite a long video, so you can't watch it all in one go. Don't worry, it will be placed on the Christmas updates page with an extensive written report later on today. So you'll be able to come back, watch the video whenever you want. You can't watch it all in one go, and you'll be able to have a read of that written report as well. The 5th Christmas update is going to be released for you later on this afternoon, so keep an eye out for that. I think that's it for all of the announcements, so let's get on with your 10th Winter 17-18 update. I say we're beginning exactly where we left off last week with the 9th update. So we was looking at winters that follow the top 20 warmest Octobers on record. And you combine all of those top 20 winters. This is the reanalysis that you come out with, and it is overall a signal for a cold winter. So we find that we've got a blocking signal over Greenland and also extending to the north of Scandinavia, and then you have the below average heights over UK to the south of the block. So you do something a bit like that with the cold, with the flow, and with jet stream, I should say. Places on the cold side of the jet, and overall the top 20 warmest Octobers on record. It is a signal to have cold winters following. However, if you have a look at the reanalysis for all the winters combined just for the top 10 warmest Octobers on record, it's not quite as straightforward or clear-cut. So the broad theme is still the same. There is still a little bit of a blocking signal to our north, but it's much less well defined. And then the trough to the south, indicated by these blue colours, that also is not in a position, as good a position as we see with the top 20 for producing cold conditions. I think the reason for that difference is that the top 20, particularly from numbers 20 to 11, the top 20 is including warm Octobers that occurred a long time ago, whereas the top 10, these years just here, is including a lot of modern years, a lot of warm Octobers within the past 10 to 15 years and the winters that follow them. And of course, the last 10 to 15 years, we have been in generally a warmer climate overall, not just in October, but for all months overall, it's been a warmer climate in the past 10 to 15 years. So I think that accounts for the difference. Yes, when you look at a long time scale, the top 20 is most definitely a signal for cold winters to follow those top 20 warm Octobers. But it isn't as clear cut with the top 10 because it contains many more modern years, modern Octobers and modern winters. Now, what I wanted to show you for to round off this warm October stuff is we've tried to pin down a couple of years. Our good friend James Ackroyd, who does all of the reanalysis, is the reanalysis guru of Gauss weather vids. James has tried to pin down the closest two years, 2 Octobers, to October 2017. So this is how the reanalysis, the 500 millibar reanalysis, looks for October 2017, the month that's just gone. And we see that we've got a strong area of above average heights to our south and also extending through the UK as well, which leaves us doing something like this with the flow and with projection. It's a very complicated pattern. So we have actually got quite a signal for northern blocking there this October 2017. It did have quite a lot of above average heights to our north. But the main thing for us is that we have this ridge just to our south, which means that we drag up this warm air from the south rather like that. So that's how October 2017's reanalysis looks. Let's see if we can find a couple of Octobers that are close. You never get like for like, never get an exact match, but these are the two that we think are closest. So we've got 2001 just here. It isn't an exact match by any means because the area of above average heights is actually centred in October 2001 more through central parts of Europe. It's still the same idea that we have the trough out to our west, the ridge over and to the east, then that trough into northeast Europe and western Russia, and so we do something like that, flow the jet stream, and we drag up those warm southerly winds. October 2001 is the warmest October on record. The winter that follows that October, winter of 2001-2002, was a mild winter. It had above average heights to the south and below average heights out to the west and also to the north. So we do something like that with flow and jet stream. A little bit, not exact though for that reanalysis for that winter, because actually December 2001 is quite a coldish month, has some wintry snaps, and then January and February 2002 very zonal and very mild. So it is a little bit misleading, that reanalysis chart for the overall winter 01-02, because there's colder weather going on in December of 2001 before it all flips to a mild zonal flow in January and February of 2002. The next October that we think is close, this is probably the closest we can find, the closest James can find, is October 1995. That one has the ridge closer to us. It is centering actually around Germany in October 1995, and again doing something like that with the flow and with the jet stream as well. Let's have a look again at the reanalysis chart for this year. That's October 2017. Let's go back to 1995. They're the two. We think October 1995 is the closest. Interestingly, 1995 and winter 95-96 is a year that's cropping up quite a lot while we're doing these winter updates. This is how the winter of 95-96 looks following that October. It is a cold winter. We have the high pressure blocking to the north, we have the below average heights to the south, very easterly winter as well, lots of easterly winds going on in the winter of 95-96. Again, it isn't a close match, October 1995, I should say it isn't a perfect match, it's a reasonably close match, not perfect to 2017, but then you never get like for like. But that's 2017, that's 2001, that's October 1995. I think out of the two, October 1995 is the closest. Was followed by a cold winter. And I say 95-96 is cropping up quite a bit this year with our reanalysis patterns. So let's move on and have a look at the ocean. So this is how sea surface temperature anomalies were looking across the globe where we did last week's 9th update. The three areas we're interested in specifically, or rather this year it's actually four. So we've got the Northern Pacific up here, we've got the Atlantic Ocean over here. We've been including the Norwegian Sea, which has been running very significantly warmer than average up here. And then also, of course, critically, we've got the ENSO region over here, which is the equatorial Pacific Ocean from Peru, just there, to Indonesia over here. That blue area that you see through the equatorial Pacific is the signature of La Nina that has been developing surprisingly and unexpectedly through this autumn. Let's have a look at the latest then, and this is the latest from NOAA for the ocean sea surface temperature anomalies. This is from the 9th of November. Let's deal with the ENSO region first of all. So further strengthening of the La Nina signature has taken place. That was the sea surface temperature anomaly area or map when we did last week's 9th update. That's the area we're looking at. This is the situation now, and again further strengthening of the La Nina signature has occurred over the past week with some quite deep blue colours now, particularly in this eastern part of the equatorial Pacific Ocean. Also ties back to quite extensive cold and average sea surface temperature anomalies around there from Chile and going up the Peruvian coast. That looks quite a moderate La Nina signal now that we've got going on there. Again, very surprising, very unexpected that we have that. Further north, let's compare back in the Northern Pacific Ocean. So that situation last week, this situation now. No real changes in the northern part of the Pacific Ocean over the past week. Over in the Atlantic, again, let's have a look what was happening last week in the Atlantic Ocean. Let's have a look at the situation in the Atlantic Ocean now. And again, no real changes have occurred. The Atlantic overall, the North Atlantic overall anyway, is running quite substantially warmer than average. We have got a little bit of blue here, possibly starting to get going again to the south of green, but it's much weaker than we've had over the past 2 or 3 years. We don't have a tripole. We wasn't expecting to have the three-way band, tripole band of warm, cold and warm. That would be the signal for a negative North Atlantic oscillation. We didn't have it in May, so we wasn't expecting to have it in the winter. We don't have it at this stage. So the Atlantic isn't set up for a negative LAO, but it is quite a warm Atlantic that we've got going on here, and it is potentially conducive to at least getting some negativity of the North Atlantic oscillation. Finally, the Norwegian Sea, so that situation in the Norwegian Sea up here from Greenland over to Norway last week. This is the situation up there right now. No real changes, possibly an ever so slight reduction in temperature has taken place again over the past week. It possibly is running a little bit cooler now with that anomaly compared to what we had back in October. But it is still very much above average, warmer than average, with those sea surface temperature anomalies up there. So that's how the oceans are looking. Now I've got a new number here on the cold and warm episodes by season chart. So this is showing all of the cold and warm episodes that we've had in the ENSO region since 1950. So, for example, that's 1950 just there. You can see that in 1950, the first half of the year anyway, there was a La Nina going on, a cold event, indicated by those blue colours. Conversely, in 1953, or 1953 just there, we have these red colours. That is a warm event, an El Nino event that's going on through 1953 and into 1954. Right, let's move down to 2017, and this is the year that we're interested in right now. So what happened is that we had that very, very weak La Nina at the end of last year. That's 2016, indicating these blue colours just here, one of the weakest La Ninas on record. We go into 2017, and very quickly we get rid of that weak La Nina, and through the middle part of the year, actually it looked like we was going to go into an El Nino through the early summer of 2017. But since then, we've seen these numbers reducing again. Our latest number for the tri-monthly period of August, September, October comes out at minus 0.4. So that's just under the La Nina threshold. So again, whether we ever get this La Nina cold event designated, I'm not sure if we will, because even though actually what we have at the moment in terms of our sea surface temperature anomaly, let's see if we can get it up, and it's just there. So what we have right now in terms of our sea surface temperature anomaly in the equatorial Pacific with this deep blue area, that is more significant and colder than anything that we saw through the end of 2016 for the winter 2016-17. So right now we have a much stronger La Nina signal here in the equatorial Pacific than we did last year, when we did get that very weak designated La Nina. But because this is such a late starter, this La Nina, it wasn't expected to happen even as early or as far back as the summer, which isn't all that far back ago. Because we wasn't expecting to get it, it's a late starter, we may never get the cold event designated, because what we've got to do to get a cold event designated is go to or below minus 0.5 degrees, so we just 0.1 of a degree off the required temperature here. And I think when we place September, October, November's tri-monthly period, which will appear just here, when we get that number, that will be under minus 0.5 degrees, so there'll be no problem with that. And then after that, we will reach the required threshold with the temperature as well. But the other critical factor is that you have to do it over 5 tri-monthly periods. So we know we're not doing it there. That just leaves us with 1, 2, and 3 for the rest of this year. And then we've got to carry that through to next year, to 2018, and do it just in those two just there. So we may be able to pull that off, but it is uncertain whether we will get the required temperature anomaly, minus 0.5 degrees, over the required 5 tri-monthly period. So we'll just have to see how that goes. But in any case, we are most definitely seeing sort of a moderate now, I would suggest, La Nina signal. The atmosphere is reflecting that La Nina state. We can see it from the SOI. This is the Southern Oscillation Index. These are the preliminary SOI numbers from the Bureau of Meteorology. These are the numbers we're interested in. Just here we have positivity of the SOI. It tells you that the atmosphere is reflecting a La Nina type setup. So we see positive numbers there. For example, on the first, the second, and the third, we're at plus 2, plus 7, plus 7. The fourth goes to plus 16, strongly positive. Fifth, sixth, seventh is at plus 9, plus 3, plus 3. So again, strongly reflecting La Nina there. And then we go down to the 8th, goes to plus 18. Again, that's very strongly reflective of the La Nina setup in the Southern Ocean between Darwin and Tahiti. And the 9th and the 10th also positive, plus 10, plus 3. So the atmospheric response is very much now into a consistent La Nina cold event type mode in the Southern Ocean that is helping to generate those cold average sea surface temperature anomalies along the equatorial Pacific. And whether the La Nina is designating as an official La Nina, certainly the atmospheric response is going to be La Nina, and this winter we do have to be thinking along the lines, and we've already looked at this through reanalysis in the earlier updates, we will be having to think about La Nina winters at the weak to moderate end of things. Right, QBO next, quasi-biennial oscillation. As I explained last week, we had our latest QBO number issued. So this is 2017 just here. So for October, the QBO came out at minus 16.79. That, again, very reflective of an easterly QBO. So we've got a La Nina with an easterly QBO. That's going to be forming part of our winter forecast, most definitely. When we come to do the forecast. We see it again on this chart. I didn't show you this last week. This is from the University of Berlin, where we've got these white areas. That's the easterly QBO. Grey areas are the westerly QBO. So that's the westerly QBO there for the winter of 2013-14. This is our last proper easterly QBO in the winter of 2014. 2015. We come down to here, and this is where we are right now. This is updated up to October of 2017, and you can see that again when we get to this sort of level just here, that is kind of like the troposphere. So that tells you, when you see these colours going down to that level, 30 to 50 HPA, that is showing that the QBO is down into the boundary layer of the atmosphere and the troposphere where weather is taking place. We see we have reached that level. In fact, we did a few 2 or 3 months ago. So we are in an easterly QBO now. We will continue to be in an easterly QBO through to winter. This is how the chart is going to look, doing something like that, and this will be our easterly QBR. I've been trying to find years on this chart, and we can go all the way back to the 1950s with this, to 1953, 1954. I've been trying to find years that are close in terms of how we see the descent to this year, to 2017. I'll probably have more on that next week. There are 2 or 3 winters, and they are quite striking winters that are standing out with that. But in any case, it definitely will be an easterly QBO winter, the winter of 2017-18. So when we come to put it all together, our good friend James Ackreel will have a spreadsheet that will put all of this together. 2 of the key points that we'll be putting together, sort of weak to moderate La Nina with descending easterly QBO. Right, Russian, Siberian and Scandinavian snow cover next. So this is how things were looking when we did the 9th update in terms of snow cover across Russia, Siberia and Scandinavia. The snow line had got into western Russia, and we got very good snow cover over Scandinavia as well. This is the very latest when I'm doing our update on Friday. So this is for Friday, 10th of November. Actually, we've lost a little bit across western parts of Russia. We have eased the snow line back a little bit, but let's change the colour. We're still doing very, very good for snow cover across Scandinavia. Again, that situation last week, this situation now. Possibly we have lost a bit across Scandinavia as well, actually. over the week, and we certainly pushed that snow line back into Russia as well from where it was last week. I'm not sure this is terribly important now. October is the key month for this in terms of the feedbacks that occur in terms of strengthening the Siberian high. So we don't tend to look at this much more from this point on. Really, but I thought I would show you that over the past week, the snow line has actually pushed back a little bit, and we have lost a little bit across Scandinavia as well. As I say, not terribly impactful now. We've really passed the point where that is interesting. Now we've got solar activity next. So this is the solar disk on outside of this day from solarham.net. Another day of spotless condition on the solar disk. No sunspots being recorded. Solar activity at Solarham is officially at very low levels, of course, because we haven't got any sunspots, and we're expecting things to stay at very low levels as well for the next few days. This is the gas weather's winter update solar activity tracker, just updated from James Ackrill. No, James is going to be watching the 10th winter 17-18 update, so as ever, a big thank you to James for getting all of this together for us. So we can see what's going on. We can see that we are now at a very minimum level of sunspot activity. The orange line here is each day's sunspot, so you can see that we've had over a week now of entirely spotless condition on the sun. A very long run now. It is becoming quite a long run of no sunspots at all. It means that the thick green and thick red lines are very much trending into a really minimum level of activity. If this carries on much longer, I think we're going to go even lower, and we will go down to a level of activity that we haven't been at before. Certainly through this part of the solar cycle. So we'll be at the lowest level we've been essentially since the solar minimum of solar cycle 23, starting the beginning of the current solar cycle number 24. Obviously, it is a big crash actually that's occurred, because at the start of the winter updates at the beginning of September, we had this big spike in sunspot activity, which really saw the trend line shooting up. Since around middle of September, the trends have been downwards all the way. A real crash has taken place with solar activity over the past sort of 6 weeks or so. I don't think we've talked all that much about solar activity for this season's update. So next week, for the 11th update, I want to do a bit more on solar activity. We might see if we can have a look at some winters that were close to solar minimum and see what those winters were like going into solar minimum, because we are very close now to the solar minimum of solar cycle 24. It's going to occur in the next year to 18 months. So this winter is going to be a winter that is close to, if not completely at, solar minimum. I don't think we'll be quite at solar minimum with this winter. That will be next winter, I would have thought. But we are very close to it. So next week we might see from reanalysis if we can do a bit more on solar activity, because I was having a chat with James and we both agree that it doesn't feel like we've had all that much to say this season about solar activity. So next week, if you enjoy all of the solar stuff, next week will be a bit of a solar special for the 11th winter 2017-18 update. And then that brings us to Atlantic hurricane activity. And annoyingly, I've got the wrong page up there. So let's see if we can go back and have a look at 2017. Right, that wasn't supposed to happen. Sorry about that. So this is the hurricane season for hurricane season page for 2017 from Wikipedia, and this is showing all of the storms and hurricanes that we've had through this year's season. So this chart is always very interesting. These charts to have a look at. This shows through these dotted lines just here, shows every single storm and named hurricane that has occurred during the 2017 Atlantic hurricane season, and their tracks where those storms went. That's always a fascinating watch. But the real story is further down with the numbers. So let's compare to last week. So for total depressions, we are now at 18 total depressions for this hurricane season. And that's up 1 from last week. For total storms, we are at 17. Again, that is up 1 from last week. So this hurricane season isn't over. It is still rumbling along, albeit at a much reduced level. However, for hurricanes at 10 and major Category 3 or above hurricanes at 6, for those two we haven't moved, so those two are kind of flatlining a little bit at the moment. The other two numbers have moved up ever so slightly, just up 1 for total depressions and total storms. This is a very big hurricane season. Whatever happens, it will certainly be within the top 20. It might even be in the top 10. And James and I have been having a look at the top 30 most active hurricane seasons. Now, the way you decipher an active hurricane season is a little bit confusing, and it's not all that clear-cut. So we may not have got all of the years right here, but these are the 30 that we've come up with. And our most active hurricane season, certainly in terms of the numbers, is 2005, which comes out at an incredible 28 tropical storms, 15 hurricanes, and 7 major Category 3 or above hurricanes. But it isn't all that clear-cut in terms of these years that have very active hurricane seasons. For example, let's have a look at 1887. So that one has 19 tropical storms, 11 hurricanes, but just 2 major Category 3 or above hurricanes. Whereas another year, let's try 1916. So that one has 15 tropical storms. It's a little bit lower than 1887. It has 10 hurricanes, again, a little bit lower than 1887. But it has 5 major hurricanes, which is above 1887. So you see what I'm getting at here? It isn't all that clear cut as to how you define an active hurricane season. But these are the top 30 that we have been able to come up with. So we begin in the year of 1870 and we go down to our last very active hurricane season, which is 2012. And quite honestly, 2017 is going to be it will be placed in this ballpark from 1870 to 2012. It will take up a place within these top 30 most active years for hurricanes. So let's have a look at the winters that follow these active hurricane seasons. So these aren't in an order of sort of the most active to the least active in terms of the top 30. They are actually from the earliest to the most recent. So we're starting at 1870 and the winter of 1870, 1871, and we're going through to the most recent. So we begin with the winter of 1870, 1871, and this one has a strong blocking signal. So this one looks like it should be a cold winter, but the trough isn't quite perfectly placed here. So I'm not sure if this was a particularly cold winter. It did have some cold weather. We have a bit of a southerly tracking jet stream, but I'm not sure we're quite on the right side of the blocking in the winter of 1870, 1871. Our next winter is 1878, 1879, following the active hurricane season of 1878. I won't need to tell you too much about this. It has a really strong blocking signal. Look at the below average heights that are going on underneath that blocking. Very severe winter. And very cold year in 1879. Really, really severe winter of 1878, 1879. The next winter is 1881, another cold winter following the active hurricane season of 1880. This one again has a strong blocking signature, not quite as strong as in 1879, but it is a very strong blocking signature with below average heights to the south of that blocking through the UK and Western Europe. It had contained a very severely cold and snowy January 1881. Our next year is 1887, following the hurricane season of 1886. This one is a bit different. It has lots of below average heights up to the north, above average heights over here, and below average heights over here. I think this was a pretty cold winter, although it doesn't look all that special, but I think it was a cold winter in 1886, 1887. These 1880s winters are quite interesting because these are all occurring, and hurricane seasons, of course. They're quite interesting because they're occurring through solar cycle 12. I won't say any more about that because I'll talk. As I said, we're going to do a bit of a solar cycle special next week for the 11th update. But if you've been keeping tabs on the long-range updates and the solar updates at GasWeatherVids, you'll know that for a long time we've been discussing a connection between solar cycles 12 and the current solar cycle number 24. And these hurricane seasons and winters that follow them are all in the solar cycle number 12. Let's carry on, and we go through to 1887, 1888. So we've got two back-to-back years here for active hurricanes and the winters that follow them. This is a cold winter again, 1887, 1888. It has below average heights to our northwest, above average heights to our northwest, I should say, below average heights to our southeast, and again, we do something like that with the flow and with the jet stream. That's another cold winter following an active hurricane season from solar cycle number 12. This one's a bit different. This is 1893, 1894, following the active hurricane season of 1893. This is just a mild zonal westerly type winter in 1893, 1894. We've got 1916, 1917 showing up next. This is another cold winter. It's quite a severe winter. There weren't many cold winters from 1900 to 1940, but this was one of them. Winter of 1916, 1917 on the cold side of the jet stream. So far it does appear that we have got a little bit of a trend going for these active hurricane seasons to be followed by colder winters, perhaps. This is 1926, 1927. Don't know all that much about this year. There weren't many cold winters in the 1920s. I don't think this was a particularly cold winter. Looks like it's probably quite a dryish winter, though, because we are blocking off the Atlantic. And at times we possibly are pulling down some cooler air from the northwest, but don't know all that much about winter of 1926, 1927. 1933, 1934 is our next winter, following the hurricane season of 1933, which I'm just having a little bit of a read about on Wikipedia, as you may, so eagle-eyed viewers may have noticed that. So this, anyway, is our winter of 1933, 1934. Looks very anticyclonic winter, very dry. There's quite a lot of cold weather, but mainly from sort of a mid-latitude high pressure, not much northern blocking, so not remembered as a classic cold and snowy winter. 1944, 1945 is our next winter, following the hurricane season of 1944. This one, this is cropping up a little bit in the analogues packages, by the way. It does have some cold weather, especially in January 1945. We have the ridge out to the west, below average heights to the east, and we bring the air down from the north like that. Go through to 1950, 1951. Again, this one is cropping up a little bit in the analogues packages. So this one has the above average heights to our northwest, below average heights over and to the east of the UK, and again doing something like that with flow and with a jet stream. This is a front-loaded winter, has a cold December in 1950, very cold December, and then it gets milder through January and February. So in some ways similar to 81, 82, in some ways similar to the December to Remember winter 2010, 2011. The winter of 1950, 1951 is appearing quite a lot in our analogues. 1951, 1952 shows up next. This one has above average heights to the west, below average heights to the east, and doing something like that, flow majestic. Quite a coolish winter in 51, 52. 55, 56 turns up next. So this is a backloaded winter. So a little bit deceptive with the re-analysis here. It does look as though it should be a cold winter overall, because we have a bit of a blocking signal there with below average heights just there. But what happens with this winter is that December of 1955 is mild, and that continues into January. And then at the very end of January, it gets severely cold, and that leads to a severely cold February in 1956. 1959, 1960 comes up next, following hurricane season of 1959. This one is a very wet winter and quite a mild winter as well. That one is showing up a little bit in the analogues as well, I think. Also, we've got 61, 62 showing up here, following the hurricane season of 1961. Again, this one is showing up quite a lot. 61, 62 has a bit of a blocking signal to the north, below average heights to the east. There were several really quite potent cold snaps during winter of 61, 62, and in some ways it's possibly is a winter that's laying the groundwork perhaps for what happens the following winter, 62, 63. That one is cropping up a lot at the moment with our analogues. 64, 65 comes up next. This one also is cropping up a little bit. This one, after hurricane season of 1964, places above average heights around Greenland, below average heights to our south. So again, it does look like quite a cold winter. There are many cold winters through the 1960s, so we do something like that with the flow and the jet stream. 64, 65 is another one that's quite a cold winter in the 1960s. 66, 67, don't know much about that one. It's one of the milder winters of the 1960s. Then we go through to 1970. So this is 1969, 1970. This one has below average heights to our southeast, above average heights to our northwest. Several cold interludes during the winter of 69, 70, particularly again quite late on, February into March. Lots of snowy spells then. Then we have quite a run of years where we don't have any analogue showing up. So we don't have much through the 1970s. Obviously that was a quite a period for hurricane activity. We go through to 80, 81 next, following the hurricane season of 1980. That one, again, it is cropping up quite a bit within the analogues packages, I think. That one has below average heights to our north and east, above average heights to our west. And again, we do something like that with the flow and with the jet stream winter of 80, 81. Another quite long run to 1990, 1991. And again, this one is cropping up quite a bit in the analogues packages. You'll notice there are several cold winters that are appearing here. So I think the idea that we've always had, that an active hurricane season is associated with colder winters that follow them. I think that is being borne out with these analogues. So this is winter of 1990-91, following the hurricane season of 1990, and we know what happened with this one. We bring in that severely cold spell in February. Maybe a bit of an idea within some of these years for having cold later as well. Now look at this, we've got 1995, 1996 back again. So this is the winter of 95-96, following the hurricane season of 1995, which was a very big hurricane season indeed. So again, I won't talk too much about that because we just discussed it at the start of the video, but we know it's a block winter. We know it has lots of easterly winds in the winter of 1995, 1996. That's turning up a lot now in our analogues packages, and I think we do have to take that one very seriously, actually, 95, 96, because it's not all that far, not all that long ago, and it's showing up a lot in our analogues that we are looking at this season. We've got 96, 97 next. This one has been cropping up a little bit as well over the updates. Can't take too much from that reanalysis, and should get rid of those lows because that's wrong. Actually, that's a ridge, but we've got just there with the lows out there, and again, doing something like that with flow. Let's get rid of that because that's wrong as well. So anyway, we can't take too much from that because again, the idea for winter of 96, 97 is that we have cold weather early on through December and up to New Year. Then from early January onwards, it gets milder, culminating in a very mild, zonal and wet February in 1997. 98, 99 comes up next. This following hurricane season of 1998. This one has above average heights to the southwest, below average heights to the north, and do something like that with the flow and projection. There were quite a few cold snaps through the winter of 98, 99, but also a lot of mild weather as well. And overall, it isn't remembered particularly fondly, either as a very mild winter or as a particularly cold winter. 99, 2000, so this one, very zonal winter, high pressure to the southwest, low pressure to the north, and a strong westerly jet stream coming through. That's another mild 1990s winter. 2000, 2001 cropping up next. So notice how the years are becoming more frequent again. So we start off fairly frequent with the years in the 1800s, and again possibly around the 1950s and 60s. Then we, through the 1970s and 80s, not many years in those two decades, and then from the 1990s onwards, more years are cropping up once again, telling us that there is a bit of a wax and a wane here over decadal timescales with active hurricane seasons. And we've known that as well, because that waxing and waning, I think, is occurring with the AMO, the Atlantic Multi-Decadal Oscillation. So when the AMO is colder, as it was through the 70s and 80s, then, of course, when the Atlantic is cold, there's not much energy available to power up the hurricanes. So when the AMO is warm, when the Atlantic is warmer, there's more energy available, and that's when you tend to get the more active hurricane season. So we have demonstrated that as well. It's off on a bit of a tangent, doesn't really matter for the winter update or for the winter forecast, but we have demonstrated that as well. There is a bit of a waxing and waning going on here over decadal timescales. So we're up to 2000, 2001. This one, again, has been cropping up quite a bit in the analogues packages. This one has a blocking signal to the north, below average heights to the southwest. Very nearly a really cold winter in 2000, 2001. Actually, Scotland did have quite a cold winter. It wasn't that cold for England and Wales. 2001, 2002, won't discuss that because, again, that one is cropping up quite a bit with the high pressure to the southwest, low pressure up to the north and the north. The things that would take me away a little bit from these early 2000s winters is the solar cycle, because this is around solar maximum of solar cycle 23, the last solar cycle, and that is very much away from where we are in the solar cycle right now. 2004, 2005 is our next winter following the hurricane season of 2004. So this one has a few cold snaps as well through 2004, 2005. It looks like it's very nearly a very cold winter, and it did have quite a cold end to the winter of 2005. Also contained a fairly widespread white Christmas. This is 2005, 2006. It follows the hurricane season of 2005, which is the strongest hurricane season recorded, certainly in terms of the modern era. So this one, again, we've got the above average heights to our north and northeast, below average heights to our southwest. It looks like it should be a cold winter. I've talked about this quite a bit because, again, it is cropping up quite frequently in our analogues this year. 2005, 2006 looks like it should be a cold winter, but somehow or other, it just didn't quite come together in the winter of 05, 06. 2009 next, so this is following the hurricane season of 2008. So 2008, 2009 winter looks like this, and again got the below average heights to the south, the above average heights to the north. This was the first of the cold winters that we went into a few years ago. So we have the run of all the mild winters through the 1990s and much of the 2000s. We get to 08, 09, we get our first cold winter, and then really from 08, 09 through to 2012, 2013, we get quite a lot of cold winters in that period. And in terms of a solar cycle, I would think this is getting fairly close, actually, 08, 09, to where we are right now in terms of solar activity. 2010, 2011 is included next. For December to remember of 2010 follows the active hurricane season of 2010. And this one, again, we know what happened with this very strong blocking signal, particularly so in December, has a December to remember, and then it gets milder. The cold goes away just after Christmas and never comes back. And our final year is 2012-2013, following the active hurricane season of 2012. We get the winter of 2012-2013. This is our last cold winter. So we have the above average heights to the north, below average heights to our south, to our southeast. Quite a lot of easterly incursions as well. And we know that actually it got very severe in terms of the blocking pattern and the cold temperatures in March of 2013. So finally, let's put all of these together. And as I say, it is a little bit tricky to try and pin down what we mean by a big or an active hurricane season. So the first all years combined chart is looking at winters that follow hurricane seasons that have 5 or more major category 3 or above hurricanes. We know we've got past that for this hurricane season. So what we see with these winters is that, again, it is overall, and I thought this was going on as we're going through the analogues, it is a signal for a cold winter. So we have the below average heights to our south, we have the above average heights centering to the north. It's not a guaranteed cold winter. We know there are several years within these analogues that have mild winters, but overall, combining all of the years, it is a cold signal. And then if we have a look at winters following hurricane seasons with 9 or more major category 3 or above hurricanes, and of course I think with this one it's winters following a season with 9 or more hurricanes, I should say, not major category 3 or above hurricanes. Again, it's very similar. The blocking signal is there around and just to the south of Greenland. The below average heights are around the UK and much of Central and Western Europe. Again, looks like we're on the cold side of the jet with these winters. So again, all years combined, it does look as though overall, it's not a guarantee, overall active hurricane seasons are a signal for colder winters. Final way of looking at this is through ACE, which is accumulated cyclone energy, which is kind of like the energy that these storms and hurricanes are emitting. And again, it is a similar signal, not quite as clear-cut with this. Notice the blocking is ever so slightly further south, more mid-Atlantic ridge, but overall it's close, and it's close enough, I think, to say that however we define an active hurricane season, it looks like overall, not a guarantee, but overall it is a signal for a cold winter to follow. And we are done with the 10th Winter 2017-18 update. I've got no idea how long this has gone on for. 53 minutes. So it's another real epic that I've done for you with this 10th winter 2017-18 update. Hope you found it interesting and informative. I wanted to have a really good look. That's why it's gone on a bit longer than perhaps a lot of people would want. I want to have a really good look at hurricane season because it's something we've never done before. We have, since I've been doing the winter updates, in the first one was for 2012-2013, we've always looked at the hurricane season, but I've never really gone to see what the hurricane season is doing over the course of the updates. But I've never gone in depth to see what the winters were like that followed those hurricane seasons. I've always assumed, and it is a Joe Bastardi thing, that's where I first got this from, the legendary Joe Bastardi from America. So I've always assumed that yes, an active hurricane season is has a connection to a cold winter for the UK and Europe, but I've never actually proved the fact, and I've never really looked at it in this way before. So I hope you found that interesting and informative. As we're going along with these updates, we've done 10 of them now. As we're going along, I'm sure you are seeing that many of the things that we are looking at this season are pointing towards a cold winter. And yet the one problem is that the model output, the long-range models, don't want to go anywhere near it at the moment, particularly. So that's a quandary, and it's something we're going to have to try and balance out when we come to do the winter forecast on the 3rd of December. But it is very much the case that a lot of the drivers we're looking at, sort of the La Nina stuff, the QBO stuff, the hurricane stuff, lots of the drivers we're looking at this season are pointing us towards a colder than average winter, and I think we have got to take that on board when we come to do the winter forecast in just 3 weeks' time. So that's the 10th update done and dusted for you. We'll have the 11th update next week. I say next week, I'm hoping that the 11th update will be a little bit of a solar special, because I don't think we've touched on solar activity all that much for these winter updates. So if you're interested in the solar stuff, I think we will have a look at that next week for the 11th update. And then the 12th probably is going to focus on November patterns. Then when we come to do winter forecast, we're going to put it all together. Okay, this video will be placed on the winter updates and forecast page later on today. There'll be an extensive written report that goes with it as well. So come back and have a read of that if you'd like to do that. We've got the 5th Christmas update coming up for you later on today also. But at just gone 56 minutes, which probably makes this the longest winter update so far. At just gone 56 minutes. That's all for now, and thanks for watching.